You get a fresh laptop and a fresh server. 10 minutes later, SSH works, but only because passwords are still open, the host key warning was accepted blindly, and your terminal history is full of half-remembered IP addresses. Then you harden the server, close the wrong door first, and lock yourself out. This episode is the SSH Basics tutorial checklist. One clean path from zero to key-only login, with a verified server identity and a config alias you can live with. A clean SSH setup exists to remove guesswork. The client has an identity, usually a private key protected by a passphrase. The server has its own host key, which proves you are talking to the same machine you expected. Authentication is tested before passwords are disabled. Then an SSH config alias turns a long command into a stable name without weakening anything. This foundation matters because every later topic depends on it. Agent use, jump hosts, port forwarding, automation, audit logs, and incident response. If the base setup is sloppy, the advanced pieces become harder to reason about. There are two separate trust questions. First, can the server trust you? That is your user key. The public half goes into the account's authorized keys file, and the private half stays on your laptop. Second, can you trust the server? That is the host key. On a new server, use a provider console or another trusted channel. Change to etc/ssh and print the ed25519 host key fingerprint. When your client first connects, compare that fingerprint before accepting it. After acceptance, known host stores that server identity. Later, ssh-keygen-F checks what your client has recorded for that host. The first line creates an ed25519 key. Use a passphrase when prompted. Do not leave an administrator key bare unless you have a specific automation design. The second line installs your public key on the server account. If you have many keys, add the -i option with the public key path. The third line proves key login works before hardening. The fourth line edits the server daemon configuration as root. Set password authentication off only after the test succeeds. The final line validates the SSH daemon configuration, then reloads it. Some Debian or Ubuntu systems use service name SSH instead of SSHD. So adjust that last word if systemd says the unit is not found. Here is the end-to-end pattern. You provision a small VM named labbox. From the provider console, record the server's ed2519 host key fingerprint. On your laptop, generate the ed2519 key with a passphrase. Use ssh-copy-id to place the public key on user at host. Connect once, compare the host key fingerprint, and accept only if it matches. Now create this client config in your local SSH config. Host is the nickname you type. Host name is the DNS name or IP address. User removes repeated -l options. Identity file chooses this key. Identities only keeps the client from spraying unrelated keys at the server. The classic mistake is disabling passwords before verifying key login in a second terminal. Keep the working session open until a new session succeeds. Another mistake is overwriting an existing private key during ssh-keygen. Read the prompt, especially on a laptop with older access. For password hardening, password authentication no is not always the whole story. KbdInteractiveAuthentication can still expose password-like props, so set KbdInteractiveAuthentication no when your policy is key only. Also check include lines in sshd config. Many distributions load extra snippets from sshd config. A later file can override what you thought you set. Finally, permissions matter. Private keys should not be group readable, and /ssh should not be writable by other users. This capstone closes the foundation's arc. The 10-point checklist is: install OpenSSH client, confirm server SSH is running, generate an ed251519 key, protect it with a passphrase, verify the server host key out of band, copy the public key with ssh-copy-id, test key login, create a per-host client alias, disable password and keyboard interactive login, then validate and reload SSHD while keeping a session open. That order is intentional. Identity comes before convenience. Verification comes before trust. Proof comes before hardening. Once this is stable, the next tier can build on it without explaining why the base connection keeps changing. Your practice task is small and safe. Use your own VM, spare VPS, or local labbox. Do not practice on systems you do not administer. Start with password login temporarily allowed. Generate an ed25519 key on your laptop and use a real passphrase. From a trusted console, print the server host key fingerprint and compare it during first login. Copy the key, log in with it, then add the labbox alias to /ssh/config. Open a second terminal and confirm SSH labbox works. Only then edit sshd config, disable password and keyboard interactive authentication. Test the daemon configuration, reload it, and try one more fresh login. 3 beats to keep. First, a clean SSH basic setup is a sequence: key, passphrase, host verification, copy, test, alias, harden, validate, reload, document. Second, never confuse user authentication with server identity. Your key proves you to the server. Known hosts helps prove the server to you. Third, key-only login is not the starting move. It is the finish after you have a tested path back in. Tomorrow we move into the next SSH topic in this daily Zero to Expert series. Also on this channel every day, the ranked CVE brief for administrators who need to know what to patch first.